Yeah.
you go. You're on.
Okay, so Sean, Ashley, just, it's so unfortunate that you couldn't be here tonight, but with the great resources that we have here in class, Dasi, Devora, Greg, we're flipping this class for you, okay? So you get to check this out online and come to class next week ready for part 2, okay? So this is going to be part 1 tonight. We're switching units after that wonderful series of presentations last week. We're switching units. We're starting a new unit now, and that's to be on data analysis and visual representation with an online spreadsheet app. Really what we're talking about here is data-driven decision-making as one of the standards of the National Educational Technology Standards for school administrators, okay? So basically in the unit, historically what I've asked students to do is to work in small groups. Because our class is small, there's an option to either work individually or to work with a partner or two on this project. So if you were to work with in a small group, the idea would be to collect some kind of data at your school and then to combine the data sets from the different schools together and to put it into a spreadsheet so that you can do some kind of statistical analysis. The kind of analysis that we're going to be engaging in here is called bivariate tabular analysis, which is the same as calculating a chi-square. Calculating a chi-square is really great for seeing if there is a correlation between dependent and independent variables. So for example, if we administered a survey in our school of all the teachers and how they integrate technology, but while we were interested in those questions, we were also collecting some demographic information. The demographic information, gender, years of experience, discipline that you're teaching in, for example, those would become independent variables. And the dependent variables would be the answers to the questions that we're interested in. So we'll perform the chi-square analysis, and then we will visually represent our data in histograms, for example, pie charts, perhaps, and then put it together as a talk to present in class. So that's the basic overview of the unit. Tonight, as I'm introducing the unit, what I'd really like to do is share with you what a blog assignment is for next week, and then give part 1 of a mini lecture on how to calculate the chi-square or bivariate tabular analysis. So, Greg, can you hit the back button there? Thank you. All right. Looking ahead to next week, on the 18th, assignment due, weblog query. Whoops, that didn't work. Let's see if I can get this to work. Yay. So this is the blog assignment. I'm not expecting that you can read it here, but instead, just to get a sense of it, for tonight's class, I asked you to read the McIntyre article, and based on the reading of that article, which kind of lays out some of the problems with the availability of different kinds of data in school districts, I want you to actually post a blog entry based on what kind of data is available to you and generally available in your school and what forms you find it in. So, what data is currently being collected at your school? I want you to make a list of the sources of where the data is being stored, such as databases, spreadsheets, text files, paper still. Identify the person or persons or the department that manages particular data. Are the data sources compatible? Do existing obstacles complicate or prevent correlation analysis of the available data? And in all, there are 7 different steps that I'm asking you to consider in this blog. So it's going to take a little bit of leg room, everybody, actually, to get this set up so that you can find out this kind of information at your school. Lastly, the last part of this also, MIS is a term that refers to Management Information Systems. And I'm wondering, that's like your Power School. What do you use, Greg?
Echo and Infinite Campus.
And what do you?
Schoology.
Schoology and?
PowerBook.
PowerBook, right, that's the one that I was struggling for.
Yeah,
So, Progress Book. These are all integrated teaching and management information systems. How well is the system being used? Is the system robust enough for the kinds of needs? The real question is the data you need to do your work available to you in a form that is actually useful for you. So that's the blog on data-driven decision-making, or D3. Next week in class, we'll be having a workshop review on working in, let's say, a kind of online environment like Excel. We'll review the basics of doing Excel. What I'd like to do now is turn to the mini lecture on bivariate tabular analysis. So the assumption is you've collected data. Now how are we going to try to make sense of it? And of course, the way that you make sense of the data depends on the data that you've collected. So you can only collect certain kinds of data. And we're not going to be looking for causal relationships. Instead, we're looking for correlations. Is there a relationship? Arrows not assumed one way or the other. So now, you should know that while we're videotaping this, and I will put the link in here too, the lecture is available, at least the slides are available for you here. Wow, that worked pretty well. So we'll go into slideshow mode. That's it. You got it, Greg?
It's not going though.
We can probably work with it like this. All right, so bivariate tabular analysis and calculating the chi-square. So already we're having some kind of technical problems. I'm just going to advance to the next slide, all right? All right, we don't really need that. Oops. Okay, so bivariate tabular or cross-peak analysis can be used when trying to summarize the intersections of independent and dependent variables and to determine relationships, if any, between those variables. For example, we're going to be working with an example from my research from a few years ago, where I was interested in students' understanding or perspective on electronic waste. So we can begin with bivariate tabular analysis to determine if there is any relationship between the biological gender of undergraduates at John Carroll University and their electronic waste preferences. Depending upon how our male and female subjects responded, we could make a definitive claim about the reported electronic preferences of those people. In a typical bivariate table, which is what we're looking at here, values on the independent variable are arrayed on the vertical axis. So here you have the independent variables, whoops, female, male, and the dependent variables, properly recycled, aware, unaware, put electronic device in the trash. Those are to be our dependent variables. What are they dependent upon? In this case, they would be dependent upon some kind of learning experience. So some students may have had a course or an introductory lecture. I think when I did this originally, I showed a brief video, actually, and used that as the treatment. So this is very basic stuff. Now what we see here is that we have 42 women, or females, and we have, as typical of education classes at John Carroll, we have 8 guys, and altogether the total is 50. All right? So these are the numbers that we're working with. And advancing our slide. So bivariate tabular analysis is based on the actual survey, what other independent variables besides, oh, here's a question for you guys. What, a little for Mishti. What other independent variables maybe could we have used?
Age.
Age. All right, age is completely independent of our treatment. What other kind of variable?
Socioeconomic.
Socioeconomic status, right. Residency we used.
Marital status.
Marital status. So do you live in Ohio? Are you from Ohio, I asked them. Are you from some other state? Where do you live? Suburban, rural, urban? And I also asked about college majors.
Oh, that's
You know, are you
interesting.
majoring in science, social science, humanities? And we included education as a social science, but if they were studying to become history or English teachers, that became like humanities, right? All right, so when we calculate the chi-square, the first thing that we have to do, wondering about the data that we collected, is to state our hypothesis about what we think is going to happen in null terms. It would go something like this. If biological gender has no influence on the level of awareness of the e-waste problem, then females and males would answer the survey in the same way. It's often really tricky to figure out how to state a hypothesis in null terms. The first thing that you're going to want to do is go up to a higher level of organization or generalization when you're speaking about your independent variables. So I speak of biological gender and not of male or female. It's inclusive of both. If biological gender has no influence, then the guys and the girls will answer the questions in the same way. So what we want to actually do is to test or try to reject the null hypothesis. We need to come up with some way to compare what we observed versus what we expect. Now the observed is the data that we actually collected. What's expected is that there wouldn't be any difference. The null hypothesis is what is expected. So we have the observed versus the expected in terms of frequencies. Now, moving right along here. Does anybody have a calculator? Maybe
On my phone.
on your phone, that would be phenomenal, okay? And does anybody have any experience actually writing on a smartboard?
Yeah,
You want to give it a
Alright.
shot for this one?
sure.
Okay, so you can be our writer, and we have two math whizzes back over here that'll do our mathematics for us. Okay, so first, we need to make up some numbers for the observed data based on the actual enrollment in the course. So then we can determine the expected frequency for each cell, which is the product of the cell's row total multiplied by the cell's column total divided by the sum total of all the observations. So let me point out here what I mean by that. So in order to come up with the number here of the female expected, what we would do is we would follow this formula here. The cell row total, which is 42, times the cell column total, which is 8, divided by the total number of observations, which is 50. Okay? So 42 times 8 divided by 50, and you get...
6.72.
You really southpaw?
No. That was terrible.
You're a lefty? Oh, who knew?
Are you righty or lefty?
I'm lefty.
Cool.
You know what they say about lefties.
We're geniuses.
Yeah, you're like that. You're like that.
You could probably write better than me on here. I'm terrible handwriting.
All right. I'll give it a shot. All right. So I need you guys to calculate all of these.
Oh. Okay.
You couldn't do it for us? I'll start on the males.
Okay, 1 second. Oh, he did do it for us. Dr. Shekin.
We're doing it real quick for you guys.
And we're actually calculating this for
What
Sean.
time are you
actually.
at, Dossie?
Okay. Quick. What number goes there?
42.
Very good. How did you know that?
Because you're going to divide it by, you're going to multiply it by itself and then divide it by 50. Yeah, works.
All right. All right.
Because
I'm a math genius.
taking the whole entire. You just did it.
Oh, it is really close to the expected. Well, not really. Some of them, except for the unaware.
This is terrible.
We added, we multiplied that total
Do you want me to do it?
No.
Are you self-conscious?
Okay.
8.
Okay. So if I wanted to calculate
total.
2.4, if I wanted to calculate the male expected in the unaware, how would I do it? 2.4. How did I get that number?
4 times 15,
Now use the formula.
the cell row, or the cell row total, so 15, times the column total, which is 4.
Where are you seeing 15?
at
Oh,
the
you're on.
bottom.
Okay, you're on the third.
No.
Okay, got it.
All right. So we're interested in male expected unaware.
Yeah, so isn't it 15 times 4 divided
Cell
by 8?
row, the row total
Oh, 8.
is
Sorry.
8. The column total is
15.
15 times 8 divided by 50. So 8 times, that's 40 and 80 is 120 divided by 50, which I guess is 2.4. That makes sense?
Right. Mm-hmm.
Okay. So that's the first step.
You have to delete it like I told you.
How do I delete it? Clearing, I see that. Excellent. Okay, now we've calculated our expected frequencies, and now what we can do is with our expected frequencies and our observations, we can now come up with a chi-square number. What is that number? What is the meaning of life, the universe, and everything?
Is it between 0 and 1? Is this the one that's between 0 and 1?
We'll speak of those things next week. No, actually it can definitely exceed 1. Okay?
Okay.
All right. So the number, or the formula that we use in order to do this, and which gives the robustness actually to this chi-square and allows for the small numbers, even to the extent that we can work with negative numbers, is because we're squaring our expected and our observed. And then we're dividing it by the expected. So we take our observed, and we subtract the expected, we square it, then divide it by the expected. But we don't just do this once. We have to do this with every single combination. Okay?
Don't talk.
All right, so we need some way to measure how different the results we observed are from the results expected. Okay? The results observed, the actual data that we collected, from the results expected, which is the null hypothesis. This can be done by applying the formula here. All right? We move on to the next page. Okay. The real fun part, actually, is when we're building our spreadsheet, is to create a table like this that will automatically calculate these and the other numbers as well. But getting ahead of myself, that's for next week's class. So these are the numbers taken from the last screenshot, and what we want to do is put them into the formula here and see what we come up with. Can you guys see what you can come up with? Give it a shot.
What's on your paper?
You got one? Try one, and then I'll do the rest.
Okay, hold on.
How
What are
about
you
this
doing,
one? Dossie, you do the first one, and Devora, you do the second one, and
Female
Greg,
number.
you do the third one.
Okay.
Do 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 do.
That's not Wheel of Fortune though, is it?
Little Vanna White here.
Right.
I'm mixing my game shows. That's terrible.
See, I don't have a fancy phone.
-0.2.
-0.2.
That's
Try
what I
again.
have, -0.2 for female unaware.
Female unaware?
Oh, yeah, that's what I did.
You can't get a negative number. 'Cause you're
0.2.
female unaware?
I mean, I have a -0.2.
I got
if
a
I'm being fabulously honest, but
0.083.
If I can't have a negative, then I'll
Yeah,
just.
you're right. You can't have a negative.
So it's just 0.2.
All right, so
Did you get that
female
also?
unaware is actually 0.203.
Wait, which one was I just doing?
The first one.
You're doing female aware.
Oh, I did the wrong thing.
God, we're gonna look awesome on the internet.
Do you want us to keep going?
No, I'll do the rest.
2, 4.
No, wait, I want to
Female-
figure mine out. Hold on.
And Greg, did you get yours? This is actually 0.012.
Is it 0.006?
Female trash.
Sounds like you're talking about trashy girls. I'm just saying.
I know.
Yeah, we really are gonna sound good on the internet.
Okay.
Okay,
and
I have
female-
.232. Is that right?
No.
Ah.
Close though. All right. Filling in the rest. I know it's hard.
What did I
They're
do
actually
wrong?
working with their cell phones. It's kind of difficult getting the calculations correct.
What did I do?
I don't know. You want me to do it with you?
It's not funny, I'm gonna-
1.9.
Expect or odd.
1.
I
The
did,
observed was 15
right? I did that.
minus 13.14.
I did that.
What'd you get?
1.14. 1.86.
Multiply that by itself.
That's what I did. Oh, you know what? I missed, I didn't type it in right. And then again, divided by
13.44.
All right. Can somebody calculate a
I don't
total?
have the same answer.
The number here is actually going to be our chi-square number.
You do it.
And as you can see, it's actually going to be greater than 1. You can eyeball that.
I'm not adding them together. I'm doing another calculation.
Okay.
That's right.
So what did I do
Can
wrong?
I do it right now with you?
Hold on, I'm starting again.
I got 2.507,
Here?
the bottom. Could that be right?
It's close.
All right, I'll take
15
close.
divided by-
Hold on, hold on.
Okay, so the chi-square number that we've calculated is 2.51. Believe it or not, this is the end of. Go ahead. How do I erase the values again?
Up there. Click. Yep.
Here?
Yep.
Voila.
Oh, now I got it.
All right, so this brings us actually to the end of part 1 of bivariate tabular analysis. We've calculated the chi-square number. What we'll be doing next week in class is trying to determining actually, whether or not the number that we've calculated is statistically significant, okay? And that will enter into a couple of other kinds of analyses, and we'll talk about this kind of correlation analysis, okay? So, I want to put an end to this.